Good morning, guys. Good morning. Yeah, let me clean up this mug real quick. Okay. Let me clean this real quick. All right. So, what are we going to be talking about real quick this morning before I head to work? So, this morning we'll continue the series on gas behaviors. So, like we said previously, matter has three phases, which is what? Let me close this blind because of. All right. So matter has three phases. Like I said, gas, liquid, and solid. So if you say gas, liquid, and solid, you're very correct. And in all these three phases, the matter that is contained in them behaves in a unique way. So let's say solid. Solid is very compact, like this pen, like this pen. So the matter inside this thing is so compact that it doesn't really move freely. And liquid, it takes the shape of whatever container is put in. And the matter in it is a little free, so it could wiggle. And in gas, it moves everywhere because the matter in it is so widely spread apart. So there are three phases. Now, so we are very concerned about gas and how gas behaves. And, in a lot of years ago, so there are scientists with pace setters. They took interest in behaviors of gases, and several times scientists have been able to come up with how gas behave. So yesterday we discussed about Boyle. Boyle, which says pressure and volume, they have an opposite or inverse relationship. So if pressure goes down, volume must go up. So that is Boyle's law. So today we're going to be focusing on Charles' law. Excuse me. So today we're going to be focusing on Charles' law. So Charles' law. So Charles is one of the scientists that studied the behaviors of gases. And what did Charles say about behaviors of gases? No, so Charles said at constant pressure. So the pressure must be held constant. Charles said if you increase the volume, the temperature must also increase. And it's vice versa. So if you increase the temperature, the volume must increase. If you increase the volume, the temperature must increase. So that is what Charles' law says. And an example is, so let's say you have a balloon, and when you apply heat to the balloon, so let's say a balloon is this big, and you drop that balloon inside a warm water, you will see that balloon is gonna expand a little bit. And why is that expansion taking place? Because the air in the balloon is getting heated. So once the air in the balloon gets heated, then the gas inside wants to move at random more. So it gives the gas inside the balloon more energy, more momentum to move, So that is what Charles' law says. So Charles' law says that when temperature increases, the volume also increases. So it's different from Boyle's law, which Boyle's law says when pressure increases, the volume decreases. But Charles' law said at constant pressure, so when you increase your temperature, the volume must also increase. So let's look at an example. So let's say you have a balloon which is filled with, so you have like a balloon as, let's say, 2 liters. So that is the volume of the balloon. And it's heated at, let's say, 100 Kelvin. Now, you now increase the balloon. You increase the balloon from, you increase the temperature, let's say, 200 Kelvin. So what is going to be the temperature of this balloon? What's going to be the temperature? So what did I say? I said when you increase the volume, the temperature, the volume must also increase. So in this case, we increase the pressure, the temperature to be 200 Kelvin. So what do you think this temperature is going, the volume is going to do? The volume is probably going to increase. So let's say 4 liters. So when you increase the temperature, the volume must also increase. And this is our V1, and this is our T1. Then temperature 2 and volume 2. So that is the gist about Charles' law. Increase the temperature, the volume must also increase. And there is a formula to calculate this. So V1 T1 equals V2 T2. So if you want to find V2, so we just divide everything by, we'll isolate our V. We'll put our T here, T2 here. And when we plug this in, so V1 is 2, our T1 is 100, right? Yeah. So when you increase the temperature, the volume must also increase. So if you guys are still watching this, so that means you guys are getting some value out of this. So it's actually going to be a good time to smash the like button, subscribe, and share this video. So it's actually going to help this channel go. It's relatively a new channel, so I'm trying to grow this channel so that it's going to help lots of kids and college kids to stay on top of their chemistry game. So thank you guys for watching, and watch out for my next video, probably tomorrow. And once again, it's Mr. B's Chemistry Embassy, a place where we discuss everything chemistry. All right, I'll see you guys later. Thank you. See you guys. Bye.